Hey guys, thanks for swinging by. I wanted to walk with you through another journal article today and talk to you about what took us from ChatGPT to where we are now in the natural language processing realm of AI. As you know, we've been trying for a long time to get our computer models to be able to mimic human language and make for human interaction and conversation. So this paper was a monumental step to get from ChatGPT 3, and I'm gonna try to talk to you about how it did that and what we can look forward to maybe in the coming times. So without further ado, let me share my screen with you. So this is the article. It's called the RefinedWeb Dataset for Falcon large language modeling. What they're able to do with this was use web data alone, whereas before ChatGPT 3 and similar models were all based on curated data sets that were handpicked by humans. So the curation process because as we know, to make a good natural language processing model, you have to have high quality data. That's like the number one. So that you're going to have something that's very versatile and very like a large set of data, right? Because there's just so many words and so many ways to use them. So a high quality data set's been monumental. So that's why all up until now we've had to use human interaction to decide this is what makes a good language contribution to how we use language. So humans had to pick a lot of they used a lot of technical documents and books, as well as web scraping like social media, etc. So the Common Crawl is an engine, a web scraping engine that's like always running, and it's amassed like petabytes of data by now. So it's used it's popularly used by these language models to as the web data bases. So one of the things that they have to do is, because as we know, a lot of data out there on the web is duplicated. So sometimes they're whole web pages, and sometimes they're just portions of web pages. So like this whole abstract you can see on several different websites out there at this moment in time, because it's kind of like the summary of what this article is about. And so a lot of articles will, share that snippet so that you can click and go on and get the whole thing. Well, Common Crawl just takes all of that. So the algorithms that have been run so far have had to make sure that kind of stuff is removed, because when you have too many of duplicates out there, then your model becomes weighted, and then your predictions are not able to generalize as well. They're more memorized, and they're making poor predictions about what the semantic analysis of what you're trying to say. So to be able to semantically generalize better, they've had to come up with more robust deduplication methods, and that's exactly what this article did. So this is a graphic that shows you how they've matched or exceeded the performance of previous models. So theirs is the bright pink one, and basically what this shows is that whereas other models, they've required different, like for example, ChatGPT, it required large data sets like it was used with in order to perform as well, and it was not scalable to perform with the same kind of prediction ability for a smaller data set, because it was so weighted with these large data sets. And the authors of the article are proposing that it's because the deduplication process was not rigorous enough. And so this is a table where they talk about and show the percentage of the deduplication method that was approached in the writing of the algorithms. So as you can see, the min hash was the name of the deduplication method before, and the one that the RefinedWeb was using, and it was based on way more data that's out there, and it came up with a lot more robustness of algorithms. I'm sorry, not algorithms, tokens, words, embedding, encoded embeddings and things that are able to be utilized for any NLP applications. So I wanted to point out a couple of the things in their article that really highlight the progress that they made. So here's kind of like a synopsis about the deduplication method, where they what they consider to be deduplication, and then also filtering like URLs. They developed a pipeline with over 3,000 deduplication filters, parameters. And so I'm going to show you the graphic they were able to come up with. So the common crawl is on the left. That's basically everything that's out there, and that's where it all starts. And then first removing any internet stuff that's not in English for this purpose. They remove those off the top, and then repetition, stuff that's clearly repeated, remove those off the top. And then down, they document-wise stuff that was the whole corpus, paragraphs and things that those were kicked out. And then the line-wise too, the stuff that was like, I think with their fuzzy duplication, they somewhere in here they mentioned that there were like, if there were 50 tokens, token by token, which is like a word for word duplicate across websites, they removed one of those, and so that, to try to keep all the duplicates out. So what they were able to accomplish was just a lot more refined model with, it was a huge data set that they trained on, billions of words, but they were able to come out with a lot more semantic precision, semantic variability. I'm sorry, not variability, but like, this is the way that words can be used, but this is how this is being used in this context, that kind of stuff, the encodings and embeddings and stuff. So they were able to really come up with a lot of progress with this article, and really prove that you don't need a handcrafted curated corpora, that you can actually program in it. It's not about the sources of the data or the type of data that you're trained on, as much as it's the way that you're training your NLP model. And so that was really the most monumental point of this article. And it's a really great article. Oh, and to prove the point, articles like this, like, it's kind of an intra-industry production, right? Like, people who are working in this field and who have been studying this stuff for a long time are writing these articles and using words that we all assume that everybody knows what we're saying, and things like that. For me, I'm just barely breaking the tip of the iceberg at this time. So I'm still learning about all this stuff. And so I need to, a lot of times, get my own translations of this stuff. So the great thing about what the progress that NLP is making is it's able to make things accessible for everybody. And so that's why I wanted to show you an example. Let me see how I can change my screen share. I thought it was going to be easier. Sorry, guys, I am not a pro at this at all, as you can tell. So I'm going to share a different screen. And my huge apologies for taking this long. I didn't even need to do that, but I was already prepared. So I wouldn't have had to do, here you go. Okay, so I wanted to show you, so this is ChatGPT 4, and all I was able to do was just feed the article into the language model and say, can you tell me some key points about what this paper is about? And there you go. And so what's great about natural language processing, like GPT uses, is that it's able to really make language available for everybody. And no matter where you're at and what angle you're coming from or your exposure to what kinds of words and things like that, that's what's great about GPT. So thanks y'all for coming by, and it's exciting what we're going to be seeing in the future with the interaction ability of language models like this, because of all these progress achievements that are being made in progressions. All right, thanks again. See you later.